Finding inverse by using elementary row operations. The first method on how to find the inverse of matrix by using elementary row operations is you need to form an augmented matrix in this form, where A is the matrix that you want to find, its inverse, and I is the identity matrix. Given that A is any matrix and A must be the same dimension with I. The elementary row operations include only the following operations. The first operation is interchanging the any row to any other row. How to write the operation is like this. Capital R means that particular row. For example, you want to change row 1 to row 2, and in the same time row 2 you change into row 1. The second operations, multiplying the ith row with a non-zero constant. For example, like this. The meaning of the star is the new row. Let's say you want to find row 2 star, meaning you want to form a new row which is row 2 that has all new elements. So row 2 is equal to 3 row 1, like that. Then lastly, adding a multiple of any row to the any given row. For example, like this, or specifically R1 star is equal to 3 R2 plus R1. Only 3 of these operations that you can include in the steps of elementary row operations. You must remember that you cannot form like this. Any row you cannot multiply it with any row, or you cannot divide any row with any given row. This is very important. You cannot do it like that. Do you understand? For example, given a matrix A, here is 3 by 3 dimension. The augmented matrix form, like I said before, is like this. So here is the A, here is the identity. Alright. This one is procedure for 3 by 3 matrix. There are only 6 steps. All the odd steps, meaning step 1, step 3, and step 5 is the one where you want to find or obtain a 1 in each particular leading diagonal. For example, in this particular example, here is the, for step 1, here is for step 2, step 3, and here is for step 5. Understand? All the element that I circled is the one where you need to obtain into 1. Alright, then for any even step, which is step 2, step 4 and step 6, is where you want to obtain zeros for the rows that you have not included before, either under the leading diagonal or under or above the leading diagonal, or both. For example, for step 2, the one that you want to change into 0 is here and here. For step 4 is here and here. And for step 6 is here and here. All the ticks is for the one that you want to change the element into 0. Then you must also know that we move for step 1 and step 2 to form the formula. Your reference is at the column 1. Step 3 and step 4 is at column 2. And step 5 and step 6 is at column 3. Do you understand so far? Don't worry. You might be a bit confused because this is a new thing for you. We're gonna go through examples, and by that time I think you will understand completely all the things that I taught before. Until step 6 here, you will have from the AI augmented matrix, you will have lastly, you will get I and then A inverse. As matrix A changes to the identity matrix, the augmented identity matrix changes to the inverse matrix A. Now we let A as this matrix. The first step is you change the matrix into the augmented form. Here is 2 by 2, so the identity must be the same dimension, so only 1 0 0 1. Alright, now you look carefully, because this is 2 by 2, so there must only be how many steps? 6 or 4. If you get 4, meaning that you understand what is going on. Right? So for your information, for 2 by 2 matrix in ERO, we only need 4 steps. For the first step, you need to change this element into 1. As you can see, the element there has been changed into 1 already, or it is 1 already. So you don't have to do anything. So we skip step 1. Understand? Then we go to step 2. I just copy back. Step 2, you need to change the element under the leading diagonal 1 to 0. As you have learned before, step 2 is in the first column. So here is the element. So you can see here, the element 2 here is at the row 2, second row. So you want to change everything in the second row. So new row 2. The new row 2, you want to change the new row 2 at that particular element into 0. So the old one is 2. How do you want to obtain from 2 into 0? 2 minus 2. So you need to minus with 2. 2 is also 2 times 1. Right, so what is 0? The new row 2. What is 2? 2 here is the old row 2. The old one, you minus it with 2 here is constant. And what is 1 here? 1 here is the element in row 1. So row 1. That's how you form the formula. Okay. So everything in the row 2, you must change into the new value by using this formula. Okay, we go to the next step. You didn't change anything in row 1, so you just copy back. Okay. Now we go to the row 2, column by column. So 2, by using this formula, 2 minus 2 times 1. 2 minus 2 times 1. So you will get 0. So here is 0. And then 5 minus 2 times 3, which is 6. 5 minus 6 is you will get negative 1. Understand? And then 0 minus 2 times 1, you will get negative 2. So here will be negative 2. And then 1 minus 2 times 0, you will get 1. So here will be 1. That's how you proceed with step 2. Understand? Okay, now we move to step 3. For step 3, you must obtain at the leading diagonal, which is here, into step 3 into 1. So as you can see here, for step 3, 1 is the one that you want to obtain. The old one is negative 1. Understand? So from negative 1, how to get 1? Because it's in the leading diagonal, you must not involve any other row than the leading diagonal row itself. So negative 1, you times it with negative, you will get positive 1. So what is 1 here? Is the new row, row 2. is equal to negative. What is negative 1 here? Is the old one. Understand? Okay, so now what you have, you didn't change anything in row 1, so you just copy back everything. Then for the new row, here will be 0, negative 1 times negative, you will get 1. Negative 2 times negative, you will get 2. 1 times negative, you will get negative 1. Understand? And then for the last step, step 4, okay, here you have, you want to change or obtain this element above the leading diagonal position into 0. So what you do, this is the new one that you want to obtain. So here you will have 3 the old one, minus it with 3 times 1. What is 0? 0 is the new element, and then 3 is the old one. That's the difference between star and no star. And then minus it with 3 as a constant, row 2. Row 2 because here is 1 already. That's why we change 1, we obtain 1 first, and then we obtain the 0. So what is the solution? So row 2, you didn't change anything, so you just copy it back. So row 1, 1 minus 3 times 0, so you will get still 1. Understand? And then 3 minus 3 times 1, you will get 0. And then 1, you minus it with 3 times 2, you will get negative 5. And then lastly 0, you minus it with 3 times negative 1, you will get 3. So until step 4, you will obtain the matrix here is in identity form 1001. So after step 4, you will get the final solution, which is A inverse is the matrix here, negative 5, 3, 2 and negative 1. Do you understand everyone? Alright, so let's say B is this matrix. Before we move to step 1, you write it in the form augmented matrix form, 2 1 5 3 1 0 0 1. Okay, for step 1, you want to obtain 2 here into 1. As you can see, here is 1 already, so you can, using the interchanging row, so row 1 you change it with row 2. Everything in the row 1 you change into row 2. So 1, 3, 0, 1, 2, 5, 1, 0. Then for step 2, you want to obtain the element here into 0. So the new row 2 is equal to the old row 2, because it's 2, so 2 minus 2, you will get 0. What is 2 times row 1? You include the leading diagonals on that particular column's row. So what will happen? You didn't change row 1, so you just copy back everything in the row 1. So here will be 0, negative 1, 1, negative 2. Then for step 3, you want to obtain the leading diagonal here into 1. So what is it? The new row 2 is equal to negative 1 or negative row 2 only. Because negative 1, you times it with negative, you will get 1. So the solution is 1301, row 1, because we didn't change anything. Then it will be 0, 1, negative 1, 2. Lastly, for step 4, last step, you want to obtain the element here into 1. So the new row 1 is equal to the old row 1, which is 3. 3, you minus 3, you will get 0. So since then, 3 times row 2, which is 1. 3 minus 3 times 1 is 0. So the solution is 1, 0, 3, negative 5. 0, 1, negative 1, 2. Understand? Okay. You cannot stop there yet, because since you finish already, obtain this matrix as identity. So the inverse of B is 3, negative 5, negative 1, and 2. That's how you solve or find any inverse of matrix 2 by 2 by using elementary row operations. Anyone?